The underlying concept of a Markov chain model is a transition probability matrix, of which we have an example here. The idea is that there are various different states in which an entity can exist. And we are looking at the probability that any one individual entity will transition from its current state into one of the other states in the next period. So this example is Moody's one-year transition probability matrix for the rating of a business. So here we have a AAA business, and it has a 91.9% probability, judging from historical data, that it will be rated AAA next year. It has a 7.4 probability that it will be rated AA and a 0% probability that it's defaulted. So each row, as you see, sums to 100%. Because each of these different states, as a total, describe all of the possible states that the entity can be in. You'll notice that once an entity or business is in default, it remains there. So it has a 100% probability of remaining in the same default state. This is sometimes called an absorption state. Now, if we tramp this matrix, we can predict for a certain number of entities in each of the original states how many will be in the other states in sequential years. So this is a one-year probability transition matrix, but we can multiply the matrix by itself to figure out what the probability is of being in the different states after 3 years. So in here, in this cell, I'm going to enter the value 2. And under the assumption that the basic system is behaving in the same way from 1 year to the next, this function here calculates the probability of transition over a 2-year period. This is an ModelRisk function called Vose Markov matrix, and it is simply the multiplication of the original matrix by itself. I can see what happens if I change this net forecast period to something very extreme. For example, I'll put in 100 years. Now, arguably, the system will not operate in exactly the same way for a continuous 100-year period, but you can see what the effect is. After 100 years, you will see that any entity in one of these original states has a very high probability of somehow becoming default at a 100-year period. You can see from this matrix that any entity that has one of these ratings has a high probability of being in default after 100 years, if we allow the assumption that the system will operate in the same way for 100 years, which of course is quite unlikely. Let's set this back to 1 year. Now, if I have a portfolio of these assets, so 22 assets which have a AAA rating, 38 assets which have a AA rating, etc., it's a total of 100 assets. I might ask myself the question, in 1 year's time, what will those assets have a rating of? And this is modeled using the Vose Markov sample, where the inputs are the Markov transition matrix and the number of periods and the initial number of entities we have in each state. And because it's a probability model, if I hit PF9 key, you will see that these change, but they all sum to 1 at all times. Now, what can be interesting is to look at not just whole integer years or periods, depending on how the matrix is defined, but some fraction of that, for example. So perhaps I'm interested in this portfolio, but looking out a certain number of periods or a certain number of months into the future, like 6 months' time. We can look at that model over here. In this version of the model, we're using the same transition matrix, but we put in a period of 0.5 years. So this matrix here is calculated as essentially the square root of the original matrix. So halfway through the period, halfway through the year, these are the probabilities that the entities will transition from one raking state to another. And you can see if I put in 0.5 here and I multiply that by 2, so that means I'm applying the 2 times 0.5, you see I get the original matrix. In here, I'm modeling how many of Essex I will have in each class over a 0.5 year or half a year period. Let's go back to the original model. Set it to 50, say. And if I click on this cell, one of the cells from the Vose Markov sample, then under the ModelRisk ribbon, I take on view function. You can see how this is evolving. So for example, let's just put the variable mains in to make it clearer. For example, you can see here the default, the number at default, it started at 0 and it's gradually creeping up, ever increasing and never decreases, because once you're in default, you can never get out of default. You can see that the number of assets that I had in my portfolio over a 50-year period go up, and it's currently sitting at a high number, 33. If they hit the F9 key, you will see how the patterns change every time. Let's now look at a more common kind of model. Here in this tab, I've created a subscription model. In this subscription model, you've got a gymnasium. You've got a number of prospects that come in, so people who are considering joining the gym. And we're looking at some data we maybe have in our CRM, our customer relations management software, and see how many of those people that were prospects went into these various states. So the states are, it's a prospect, we have 1 year subscription, 2 year subscription, and in the first year, 2 year subscription in the second year, 3 year subscription in years 1, 2, and 3. They took a break for a year, they took a break for 2 years, and they disappear further. So here we have the prospect, 3% chance that they remain a prospect. In other words, they haven't decided to join the gym this year, but maybe they will next year. 7% take a 1 year subscription. 4% take a 2 year subscription, in which case they're in the first year, they can't be in the second year. 2% take a 3 year subscription, in which again, they can be in the first year, not the second or third, etc. And 84% are gone. Now, the 84% is 1 minus the sum of all of the other probabilities, because it must add up to 100%. And you can go through this model and follow the logic of why some of these are inputs, once some of these are impossible values, they must be 0, and why some of them are calculated. Then we enter into the model how many we have in each of these states. So we have 78,000 who are prospects who've investigated whether they'd like to join the gym. We have 7,300 who have currently a 1 year subscription, etc. Now, each year we will have new prospects coming. So in this part of the spreadsheet, we're looking at the minimum, most likely, and maximum variation on the total number of prospects we've had this year that will occur next year. So we're simulating uncertainty about how many plus or minus around our current number, how many new prospects we might get into the future. And you can see that we're becoming progressively more uncertain. So 95% is a minimum the next year, and then it becomes more than 1/3. So it could be as little as 85% going out into year 7, but it could be 110% as a maximum. Next year could be up to 120, 125, 130% going out into the future. We model the uncertainty around that using a Vose time 3 estimate, which is subject matter expert, 3-point estimate. This is a time series forecast, which is easy to understand if you click on the view function. Here you see the upper bound, so 110% going up to 130%. The lower bound going from 95% down to 85%. The most likely, which is a static 100%. And this is the forecast of what actually might happen from one year to the next. If I hit the F9 key, you will see it going up and down. You'll notice that there is a correlation, meaning that if it's likely to do well in 1 year, it's more likely to do well in sequential years. If it's likely to be around that 100% in 1 year, it's likely to stay stable in the following years. And here, if it's likely to go down, it's likely to keep going down. We can achieve that through this correlation factor of 0.9 there. If we add on what the annual membership figures for each of these categories, so for a 1-year subscription, it's $162. For 3 years, it's $149 a year. For 3-year subscription, it's $138. We can build a model to forecast how many members we might have in the future and how much revenue might be. So in this Markov model, you can see it draws Markov sample, and it's picking the number we have in each of these different categories for this year. And it's using this probability transition matrix up here. So this is forecasting what will happen to those individuals in the current year next year. So where will they be in the next year? So from this point, we move to that point. But then we need to add how many new prospects we will have next year and what they will do. In this table, we're taking into account how many individuals we had in each of these different categories. And we're adding the new prospects. So in this cell here, we're looking at the transition to being a prospect in the next year, so they hadn't decided, plus a number of new prospects that we expected, which is 101%, simulating the uncertainty about comparing with last year, multiplied by how many prospects we had last year. And that's the only row that changes. The rest of it are just simply referring to how many prospects, how many 1-year subscriptions, 3 years, etc. we had in the previous year. And we don't bother about including the ones that are gone. So this Markov chain model is forecasting into the future how many individuals we had in each of these states right now, incorporating anything we might have done to increase or decrease the number of prospects we get to the gym in the future years, and looking at how people transition from one subscription to another. Then, very simply at the bottom, we are looking at how many members we have, which is how many have 1 or 2 or 3 year subscription. And we're looking at how much money we make from each of those different subscriptions. So these are the fees that we earn from the annual membership, multiplied by the number of people in each of these groups. We name this as an output. It's given the label year 1. It's called the series. It's called gross revenue. And this is the first period in that series, and the next one, the second period. In other words, we created a time series over 7 years of a forecast for the gross revenue. We've done the same thing for the membership. And at the very end here, I've calculated the total number of members we would have had over the 7-year period and the total growth revenue we would have had as well. Again, these are both outputs. Then when I run a Monte Carlo simulation model 5,000 samples. When the simulation's finished, it shows the ModelRisk results view. We have output here, the histogram of the total gross revenue. We can look at, for example, the cumulative of total gross revenue, or perhaps the total number of members who we've had over the 7-year period. We can look at a trend plot of the gross revenue. So you can see year on year that it's going slightly down, and there is some increasing uncertainty out into the future, as you would expect. And similarly, we can look at the number of members, and you can see that this is projected to go down slightly with an ever-increasing uncertainty as time goes on.